Okay, so let's go over some cloth sim basics, and I will actually give the default cube some purpose today. So first up, the cloth sim is a physics simulation, so you can find it in here. And the cloth sim algorithm needs geometry to work with. So when we go into edit mode, also let me just quickly switch on the screencast keys here so you can see what I'm doing down here. So we go into edit mode, right click, subdivide, and then go in here and give it like 20 cuts. So we have some geometry here in this cube. And when we enable cloth sim and hit play, all it does is fall down. So I can bring it up a little on the Z-axis, maybe add a ground plane and enable collision on this ground plane. So now what do we have now? Oh, we have some cloth sim and it all just falls in on itself. And first thing we can see right away is we have some issues with the collisions because the cube is colliding with the ground plane, but it's not colliding with itself basically. So let's see, we have some options here in the cloth sim settings. First of all, we have quality steps. We can turn that up if we have some issues regarding collisions and all that. Then we can change the speed. So if I go back with shift left key and hit spacebar to play again, this is the speed we have now. But if I set the speed multiplier to 2, you can see it acts faster basically. Okay, then we have vertex mass. So our cloth has a certain weight to it. And we can set that down. For the standard flag, you would set that down probably, and then add a wind force field. So each vertex now has a weight of 300 grams basically. And we can play with this. We have air viscosity, which is the air in our scene is slowing down the fall. That's basically what that does. And then we have the actual cloth stiffness, which is divided into tension. So how much does this cloth resist pulling? And compression, how much does this cloth resist compressing? Shear is when the cloth is sliding on top of each other. And bending is a factor how tiny the wrinkles or the creases are when it collapses on itself. So you can turn this up and then it resists bending some more. We will look at that. Then we have the damping here. I actually never ever touched this. But of course, just like with any physics simulations, the real trick here is to just go in and play with all of the numbers and all of the features and try it out. Okay, then we have internal springs. So what does internal springs do? Let me just switch this on. How big is our cube? Right now it is 2 by 2. That's the default cube. And then we have the max spring creation length. So set that to 2. What does that do? Basically, each vertex is going to have a spring inside to an opposite vertex over here. So if I set that to 2, the spring in there will be long enough to reach from one end or from one side to the other. And if I hit play now, you can see it doesn't collapse anymore. So basically what this is like a mattress with springs inside now. If I set that down to 1, shift left spacebar, you can see the springs inside are too short. They're not reaching from left to right or across the entire distance of the cube. So this is what we get. Also a cool effect. So this is the springs inside, and again you can change the tension, compression. You can apply a vertex group, which is a feature here used very often. All of these features can also be just limited to a certain vertex group, and we will play with this also. Then we have the new pressure feature. The next 2 videos in this series are all going to be about pressure, so we'll talk about that then later. Cache, of course, is like with all the caches in Blender, you can bake your physics simulation to a cache, which you should do before final rendering. Okay, then we have the shape and a pin group. What is this? So basically I can go in, I can pick a vertex or many vertices. Let's pick, I don't know, this one and this one. And then we go over here, create a new vertex group, maybe even call it pin, and assign these two selected vertices to this group now. And over here in the cloth sim, I can now pin these two vertices, which means they will not change their position. They will be stuck right here, and just all the other vertices are now part of the cloth simulation, and it looks like this. Okay, so that's what pinning does. In the shape menu here, we also have the shrinking factor. So we can, let me just take away the pinning. We can also tell this cloth, if I switch off gravity down here quick, we can tell the entire cloth simulation to shrink down a little. And then that's what happens. Okay, so we have a little bit of shrinkage. Usually you would go to something very small here, just to have a little bit of a shrinking effect. And maybe we will be using this later too. So shrinking. Then we have collision. By default, the object collisions is switched on, which is why if I switch gravity back on, the cube falling down collides with our ground plane. Of course, you have to enable collision on all the collision objects that you want to have in your scene. And then you also have soft body and cloth settings here on the collision objects. And usually you would want to turn this thickness outer down even more and make it a very small number, because sometimes, or right here, you can see that this is where the ground plane is, down here, but we have some distance in our calculation, and that comes from the collision settings and also from the collision settings in here. In the object collision, you also have a distance here. And then we have this option here, self collision. And if I switch that on, we will notice two things. First of all, the simulation becomes much slower because self-collision calculations are very hard to do. But you can see this looks much more realistic. It's not colliding or it's not intersecting with itself. It is actually colliding with its own mesh or material or cloth in this case. So this is what it looks like. Much nicer. You can also set the distance here. Just like the distance you have with object collision, and you can use a vertex group here to limit the self-collision to just certain vertices. And then we have property weights down here, and this is another feature where vertex groups come in, so you can define certain vertices in a vertex group to have certain tension compression settings, certain shear settings, bending settings, and shrink settings. So let's quickly see what that looks like. Maybe I'm gonna hide the cube or you know what, get rid of it completely so it doesn't slow down. Let's just take a plane, bring it up, right click, go into edit mode, subdivide like a bunch of times so we have a lot of mesh to work with. Then let me just rotate it like this, maybe. Okay, now make a cloth simulation out of this and let it fall down onto our ground plane. Now this looks very, very plain. Nothing special going on here. So we have to play with some of the settings. First of all, we can go to the collision object, to the ground plane, and turn up friction so that when the cloth falls down, it actually sticks to the ground and then we get wrinkles. We can actually rotate this even more maybe. Go shift left arrow, space bar. Now we have a cloth simulation. Now let's look at this feature where we could actually define different bending values. So circle select, take some vertices here in the center, create a new vertex group, assign those. I'm just gonna leave it as group. And then we go down here and tell the bending group to use these vertices now. And here we want to resist to bending. So instead of 0.5, I'm gonna set this to 5. The rest of the cloth is using a bending of 0.5. Now what does that look like? You can see we get wrinkles on the outside, but this center part here resists to bending, so it wants to stay flat or straight. It doesn't want to have wrinkles in it. Now, for rendering, we can actually apply a subdivision surface modifier after the cloth modifier. Give it some higher resolution. Again, we have self-collision here, so we might want to go back and switch on self-collision here in the collision feature. And then we get this. And then finally down here, we have the field weights. Just like with almost all of the physics simulations in Blender, you can define that this cloth simulation should not be affected by gravity, and then nothing happens when you play, it doesn't fall down. And also all the other types of force fields. Here, for example, for the typical flag that you see very often with cloth sims, the wind effect is what you need. So let's check out one last thing. I'm gonna delete this again, create a plane, move it up on the Z-axis, because I want to talk about wind real quick, or actually the air. So again, go into edit mode, subdivide this 20 times, and then make a cloth simulation, and watch what happens when this falls down. We notice that although we have the air viscosity set to 1 here, what you would expect if you had real air and this was like a blanket is that you would have some air build up in the middle and make this shape like bulge out in the middle. Sort of a ballooning effect. So the edges would fall down faster because the air resistance in the middle would be higher. But we don't get this here. So this air viscosity feature here, which we can turn up to 5, just slows down the falling. So that's all it does, it slows down the fall. See, now it's really slow. But it's not calculating actual air. If you want that, you would have to go in and add a wind force field, which by default is in the center pointing up. So that's already cool, that's already what we want. Turn up the strength, turn up the flow. And then let's see what that looks like. And now we get a falling blanket that looks much more realistic, because the wind is actually pushing up in the middle, and then the corners fall down faster. And this is the effect that I was talking about. This is what you would expect from a falling blanket. So that's the thing about the air viscosity. This is just a factor to slow down the fall. Okay, now how strong is this wind? So maybe what if we turn it up to 500? What happens? Cool. But the blanket is still too heavy to resist, to fly up or float away. Now there's two things. First, we can increase the strength, or we can make our blanket lighter with this vertex mass here. So if we just set this to 0.1 and play, whoa, it flies up. Okay, so we have multiple settings that work together here. The weight of the cloth is basically set here with the vertex mass, and then this of course plays into the other forces in the scene. So now we would have to turn down the wind strength again. Can we make it float just It still falls down. 170. What happens? Oh, now it's almost staying still. But you can see the force field, the wind force field, is only in the center here. So always play with all the values. You can really quickly come up with some cool looking stuff. For example, let's turn this into a blanket hanging on a wall. I would rotate this ground plane, maybe make a wall out of it. Okay, now we take this blanket, maybe pick this vertex, add it to a group, call it pin. So now this vertex is pinned. If I go in here and go to, where is it, shape pin. So now this one vertex is pinned. The rest is going to fall down because we have gravity. And then we get this, which is a blanket hanging on a hook on a wall. It didn't even hit the wall. So maybe we should bring the wall in closer, but not too close. Does it hit the wall now? Spacebar. Yeah. So now we have something cool looking. It looks like we have a blanket hanging on a wall, and it's really that simple. And of course, you always have to add subdivisions and shade smooth. And then you have this. Now here we have quite a resistance against bending. So if we don't like this, we have to go in and maybe turn the bending resistance all the way down. What does that look like? We get a little bit more wrinkles. Oh, and I think I have to switch on self-collision also. So now it looks like this. If you enjoyed this tutorial of the Practical Cloth Sim series, please smash the like button below and consider subscribing if you're new to the channel. I read all the comments, so please drop me a note and let me know what you think. Thanks for watching. See you over in the next video.